So, as I told you, my name is Antonio Iera, and I'm also the director of the Laboratory for Advanced Research into Telecommunication System. And today I will talk about the novel paradigms that you will have for sure heard about, called Internet of Things, and the new vision of Internet of Things, which goes toward a direction of Internet of Social Things or Social Internet of Things. You will understand what I mean by this. First of all, I would like to point out something about the definition of Internet of Things. Because Internet of Things is a really strange term, and different people, different research groups look at Internet of Things in a quite different way. So the one possible definition, and the most logic, is that Internet of Things is a worldwide. This is the definition of European Commission. It's a worldwide network of objects which are interconnected with one another and exchange information. When we talk about object, we intend object of any type, from PC to mobile phones, down to very small devices like a RFID tag, for example, or very resource-constrained object. The major characteristics and also the problems derived from the fact that this is an architecture with a scalability problem due to the huge number of objects that can be interconnected to it. Heterogeneity of the device is also a potential threat to the development of this kind of paradigm, and pervasivity is the characteristics because all these objects are scattered all over the world in any real life environment. The importance of Internet of Things is testified by the fact that in USA, for example, the NIC, the Agency for Security, put I think we are not responsible. Put Internet of Things among the 6 civilian disruptive technologies. So it's the famous painting is making noise. So he put among the civilian disruptive technology that will impact the US power, so for 2 years in a row. And not only in USA, but also in Asia there are huge investments. In China there is just the first Internet of Things city, one. And in Europe there is a cluster of European research projects who funded a lot of research. The fuzziness of Internet of Things starts with the term Internet of Things. In fact, this is one paradigm, but there are different, as I told you, there are different ways to look at Internet of Things. It depends, the vision depends on the approach to the development of this new paradigm. But I think that this is due to the fact that it is, the name is composed by 2 words, object and Internet. So we can look at this new paradigm by starting from Internet, so by starting from a network-oriented vision, or by starting from an object-oriented vision. And also, as the the amount of information exchange will become huge, there are also some semantic-oriented vision toward the realization of Internet of Things. What is important is that, the difference depends on the interest, but it's important that the paradigm will be the result of the convergence of this issue, as depicted in this figure. If we will look a little bit at the things-oriented vision, we can say that this is maybe the first idea of Internet of Things, because the name Internet of Things has been introduced by the Auto ID labs, which are involved in research dealing with RFID. Not traditional RFID, but RFID are the radio frequency identifier, which have been now studied within a platform, a worldwide platform, the APC Global Network, in such a way to address an object with a unique APC address all over the world. So they started from this vision, and they started to think to integrate into the RFID platform, the APC Global, also sensor, actuators, and now there are also some example of APC SN, APC Sensor Network platforms. So this is a typical vision who starts from the object. Other visions starting from the object are the one of Professor Ken Nakamura, Ken Sakamura, who was the inventor of the UED. And UED are also some, are very similar to RFID, are some device which was born for traceability. And the solution is a middleware-based solution. But anyway, starting from any kind of object, we have different vision, because we have a great experience in sensor networks, so we can start from sensor, or near-field communication, we can start from near-field communication, and so on. Oppositely, the vision that starts from the internet starts from the idea that internet is there. Internet connect worldwide a huge number of PC. Why not to start from what exists and adapt it to the object? So the first approach is the one of the IPSO Alliance. IPSO Alliance, which is IP for Smart Object, which introduced the 6 LoWPAN, which is IPv6 over low wireless personal area networks, which is a solution who try to adapt the TCP/IP, especially the headers, to the resource constraints device. Other similar approach is, for example, Internet Zero, which also aims at reducing the burdening of IP to fit the requirement of small object, and also other approach that start from the web and from the services of the web of services, and try to move to the web of things by looking at the things like services, and so make it available over the web. This is the typical approach followed by Professor Guinard and the project Socrates, for example. Then, the last one, the semantic-oriented vision, there are some papers, there are not specific project on this still, but the idea is if the number of devices will grow, the information, the amount of information will be huge, so it's better to use some semantic technology to describe things, to make some reasoning on the information and on the generated data and so on. So this will be part of the Internet of Things. Application, I think applications are only limited by fantasy, because object can be any kind of object, so we can think of object working for transportation and logistics, for healthcare, smart environments, personal and social environment, and also there are some examples, some projects which use new objects to implement futuristic project like the one I have just described here. But there are some reasons on a change in the vision, I think. The reason is sketched here. As you can see, this is, okay, I sketched this one, so it's not precise, but I took from some document on the web. As you can see, this is the growth of the user internet, and this is the growth of the internet device. So devices and objects connected to the internet. Around the next few years, in the next few years, they will grow very much more faster than the user. This means that all the approach that now people are trying to implement for Internet of Things, so starting from some island of object, maybe a sensor network and, or an RFID domain. And then through some gateways, this is the six-lovupan approach, through some gateways to connect this island over the IP backbone, IPv6 modified backbone, well, this could be very tough to be implemented. And so, due to problem of scalability, and also another problem that will appear is that is the one that you experience. If you look for information, you will find information on the web for sure, but you will find a lot of versions of the same information, and just a few of them are trustworthy. So, also trustworthiness is important. So, we think, I say we because I'm working on this idea with two other colleagues from University of Catania and of Cagliari. The idea is to think about a social internet of things. So interconnect the object through the principle which are today driving the social network of human beings. Why this? This has to be done, we think, to give to the network a structure that can be shaped just to guarantee network navigability by using the typical paradigm used in social network. All of you, I think, have heard about the small world phenomenon. Each of us in the world is related in a very few number of hops with anyone in the planet. And there are some very interesting studies from done by this colleague at Columbia, Kleinberg, who are demonstrating that this number of steps to reach anyone in the world just have been reduced by the presence of Twitter, Facebook, and so on, because friendship is closer. And so, if we give a shape to the Internet of Things similar to the social network, we can use to navigate this network also tools typical of the social networks. And also we can have this level of trustworthiness cause, as you can imagine, having an information from an object which is, how many people are passing? Hello. So, just less. So I told you, having an information received from a friend within bracket object is better than having is more trusted than a generic information. Some example of putting together object with an idea which is similar to, but not the same, of a social network are, for example, the idea of allowing people who are connected through Facebook to also share their objects, so their devices, personal device. These, there are some literature on this. And another interesting approach is the one of Pay2B, which is a platform where a lot of objects, sensor, actuator all over the world are connected, and the people can build some application on it. The idea that we are looking for is different. We would like to develop a social network of things in which things can act autonomously, but under the supervision of the under the supervision of the human people, but without direct intervention. Why people now socialize and why things should socialize. These are the main reasons. These are generic reasons. Humans to increase popularity, find friends, and so on. You exactly know why. Things, if we look at things like services, well, things have also the, some exigencies of publish the services, find the services, get environment characteristic to implement the services, and so on. So in a world of billions of users, we think that structuring the system like a social network could help. But structuring as a social network means that we have to define some kind of social behavior among objects. Which social behavior? We started from the human social behavior. As you will see, there are some basic relationships such as family relationship, people who live together, people who work together, people who socialize due to many reasons and that meet, just simply meet. Well, starting from this, we can define a parental object relationship, which now is defined in a different way. Family is substituted by the production batch. If I produce a an object, then I can also associate this object with other objects built in the same industry. Then this object will be spread all over the world, and this will give the long bridge which are very, very useful for the small world phenomenon I have talked about before. So to navigate very quickly a huge network. Then collocation relationship for object is quite common sense, because we just think about home automation. In a home, in the same location, there are a lot of very heterogeneous sensors, and so these are all collocated. They can have a sort of relationship among them. The same is for objects who belongs to different group, but that not episodically they found themselves working together. So they are trusted. This is important. So they can establish a relationship, a priority relationship. For example, all the sensors used in emergency network by the fireworks, and the other object of the policemen that meet to work together. Then there is social object relationship established among objects that belong to friends. So this is also very easy to understand. And also this one, which is typical, is not human, but is typical of object only, is the relationship based on the ownership. All the objects belonging to the same person can be supposed to be friends among them and associated to one another on the platform. This is not enough, because when we define the kind of relationship, we have also to define which is the relational models. So how an object which is in a typical relation with another one can act with the other one. There is a huge literature not in telecommunication. We found this in, as you can see, psychological review and so on. And this is the most accepted model for human. Four elementary model of the FITCE theory: communal sharing, equality matching, authority ranking, and market pricing. These are the basic kind of relational model among human. Are they extensible, can be extended to the object? Well, we try to make this kind of reasoning. For example, the communal sharing, what means is a sort of relationship in which the individual has no importance. The individual is just part of a group, and so the relevance of the individual is lost. The relevance is of the group. Let's say a rugby team, not a football team, well, because individuality, but a rugby team, it's okay. And as for things, well, if you think there is the idea already of the swarm, sensor who work in a swarm, sensor and other objects who work together to achieve the common services, and which are not important. In a swarm, it's not important as a single sensor, but it's important the services that is offered by the whole community. So this kind of relationship can be, of this rational model, can be implementable through some profiles suitably defined. What about equality matching? Equality matching is a relationship among friends. We are all equal, we are friends, we have the same we have the same importance in the group. Well, this is this can be implemented among objects which works together, which have the individual relevance. For example, objects which each of one offer a given services and that work as a peer with the other object. A peer-to-peer relationship of object, of PC, of any kind of devices is a good example of equality matching relationship. Here, the service has to be associated directly to the single object. There is this other authority ranking which has been introduced to model in the human example, to model the relationship like hierarchy, military relationship, and this can also find a correspondent concept among objects. Because if you think how it works for the sensor, for the Bluetooth devices, for RFID, there is a reader and there are a lot of tags, RFID tag. There is a master in Bluetooth and other slaves, or there is a sink and other nodes, networks, sensor network nodes. So this kind of relationship, this unbalanced relationship can be also extended to this kind of object. And the services in this case is associated, logically to the master. The last one, this is, is the most difficult to understand maybe. This is a kind of relationship which is based on, by definition, on proportionality with interaction organized with reference to a common scale of ratio values. This means, I understood by looking at the literature, psychological literature, this means that is a relationship established when it's worth to do so. For example, in a sort of marketing relationship. So we make something together because both of us as an advantage in doing so. Otherwise, we are not friends. So it's a strange sort of relationship and friendship. Anyway, among devices, this can be also found because there is a huge literature. I also worked on this of some devices which work together in cooperation to achieve a common goal. An example is we, together with the University of Holborg, the group of Professor FITCE, we made an interesting with Nokia. We make an interesting application of different mobile terminal who access the same content, but they split the content. Each one of them download just a part of the content, and then they exchange the content through Bluetooth interface. In this way, all of them reduce the energy wasting and also pay less money for the download. This is a typical cooperation which is established because it's worth to do so, to doing this. And for this reason, this could be a good example of a market pricing relationship. So, this is just some application that we think about, and also the mapping among application, type of object interaction, applicable relational model, and category of relationship. But if you are interested, I can give you a copy of some papers, so just to give a more... oh, great. This is... This is not how it should appear. Anyway, this was a little bit of imagination. This was the representation of the architecture we thought that could be implemented. As you will see, here there is the typical number of components of a social network. Here, you cannot see, but there are the I don't know why, but there were on the original slide, yes, on the original slide, the component that we thought about that are typical of our social Internet of Things. As you will see, these are a module that serves for the social presence, the participation model, which is used to define which is the way I want to be seen in my social network, and so on. But, well, some of them, with the exception of the service API, some of them are not, have to be rethought in a vision of a social Internet of Things. For example, social graph is not useful, but is substituted by a relationship management model, and so on. I'm sorry that there are not the components, but are all the components that are required to implement and to handle the relationship model I have already shown you. And then the architecture is a typical layered architecture with the object, the information, with an object abstraction, and then a layer of application. Just to conclude, as you have seen, this is just an idea. This is we produced some position paper on this, but the community already accepted some of these ideas because we have a couple of work already accepted and published. What we have done is to introduce the social Internet of Things, but a lot of things remains to do because now we have to try to implement this. We are also trying to put together a partnership to participate to a European project. If someone of you is interested in one of the aspects that could be covered by this topic, just show up. And we are now statistically analyzing through simulation the structure of the relationship that will form in a community of objects. We are using a tool which has been developed by University of Rome, La Sapienza. It's called SWIM, a Small World in Motion, which models the relationship of human being. We just change a little bit this tool, and now we are simulating how these, the objects can create this, their social structure, just to derive some equation, and then to change, to find a way to change the parameter to make the graph, the network graph, navigable and in an easier way. In this way, we hope that we hope to achieve some advantages in terms of service discovery and other aspects by using all the paradigms that at the moment are only used by social network of human being. Okay, so that's all.